So we are going to look into inheritance and interfaces. We have already discussed inheritance, all right? So we are going to be looking at interfaces. But before I talk about interfaces, we have to look at abstract classes, all right? So we are looking at abstract classes and interfaces in that. Okay, so what is an abstract class? An abstract class is a class that cannot be instantiated. Alright, so as you can see in previous lessons, we are able to instantiate, all the classes that we created, right? We are able to instantiate our classes, but abstract classes in that can't be instantiated. Alright, they also contain abstract methods, okay, which are methods with no body, alright, without a body, concrete methods with implementation, and they can also contain fields. Alright, so this is an example of an abstract class. Okay, this is should I say, a syntax for an abstract class. It simply means what an abstract class looks like. Abstract class is that. Alright, so this is what an abstract class looks like. Okay, so just like a normal class, but in order to make a normal class to be abstract, you just have to attach this keyword to it, and it is now abstract. All right, so that is just how to create an abstract class. Okay, but then a normal class the methods in a normal class must have a body. All right, they must have a body. Unlike in abstract classes can contain abstract methods. In other words, methods with no body, without a body. All right, so your methods must look like this in a normal class. All right, just as we have in all these classes. This is a method with a body. All right, and so is this. All right, I cannot remove the body and just have this. No, it must have a body. Right, but in abstract class you can have abstract methods, in other words, methods without body. Okay, so this is an abstract method, and you can as well also have concrete methods, in other words, methods with body. Okay, yeah, and as it said, you can also have properties. Okay, you can also have fields, variable, like string class name equals let's say class 5. All right, so that's that. Now why use abstract classes? We use abstract classes when we want to define a blueprint, okay, or when we want to share some behavior, or when we want subclasses to implement required methods. Okay, when we want subclasses to implement required methods. So we have an example. So let me just copy this. Let me copy what I have here. Alright, so right here you can see that we have this class animal, okay, and an abstract class method. Alright, and this is a concrete method, of course. Now remember I said that abstract classes cannot be initiated. Alright, now you can see that they say this is not allowed, error. Okay, so we have this error as well, saying abstract classes can't be instantiated. Okay, so you are not allowed to instantiate abstract classes. I want you to have that in mind. So next we have implementing an abstract class. Implementing an abstract class, and we can do that with extends, right? The extends keyword. So let's say we have a class. Sorry. We have a class dog which extends animal. Okay, we have a class dog which extends this parent class animal. All right, so this particular subclass is, or child class, is overriding the parent method make sound, as you can see. All right, so we often use abstract classes when we want to override methods. Okay, when we want to override methods. Okay, abstract classes are simply a blueprint. All right, so that when we have subclasses, we want to have subclasses that are going to implement the methods in an abstract class, right? Just as we see dog doing here. It is extending animal, which is the abstract class, and implementing this method, overriding it. All right, so that's what it is. And of course we can instantiate dog, because dog is a normal class, but we cannot instantiate animal because animal is an abstract class. Okay, now let's look at, okay, so another thing I wanted to point out is that subclasses of an abstract class, right, must implement the method. That is why we have an abstract method here. Okay, so that when this class is extended by a subclass, this makes sound, this method must be implemented. All right, so we must override it here. We must override make sound. All right, I believe in current versions of that we don't even need to use that override, this override marker. All right, we often do without it. So, but then just have it. Okay, it is good practice to have it. Yeah, because you are overriding. All right, you're actually overriding, so just put it there. So that's what it is. This abstract method must be overridden by the child class. So let's carry on. Abstract class with properties. So we have an abstract class vehicle, and car is extending vehicle. So let's see what's going on here. Okay, I'll just comment this out and this. All right, so we have an abstract class that has this speed field, this speed property, all right, which is being instantiated in this constructor. Remember, the constructor is a function. All right, so it takes this speed as its parameter, all right, and then we have this car extending speed. Okay, so this car has a constructor. Of course, it's a class. This is the constructor of the class. Okay, and it is borrowing from the super class, it is borrowing from super.speed. Okay, this speed is actually this. Okay, because of this super. So this super makes reference to the super class. All right, and yeah, this speed is inherited. All right, the inherited speed. So we are overriding this method, right, and implementing it in the process. Okay, we are overriding this method and defining it. So if I have a main function, and I just create an object of car. All right, speed is of what type? Int. So I can pass into int here, and no need to print. If I call car dot speed, no, car dot move. All right, what I get is car moves at 20 km/h. Okay, so what is simply happening here is that the child class, all right, is implementing this speed. Okay, that is what is happening here in simple terms. All right, it's implementing this speed, and of course we have this constructor, okay, that is taking this speed. Remember what I said that this keyword means. All right, it represents the current instance of the class. Okay, so it is taking this, right, and because this car is extending from vehicle, it is inheriting everything inside vehicle. All right, it's inherited this. Yeah, so it's inherited, okay, this class actually has its own constructor. This constructor belongs to this class. All right, it doesn't really have anything to do with vehicle. Okay, this very constructor. But then what this operation means is that we are passing super.speed into this constructor. In other words, we are giving this constructor this parameter, right, the value of super.speed, right? So even if I instantiate vehicle, okay, I cannot even instantiate vehicle, all right, but then when I eventually call my method, all right, whatever I pass from calling this constructor in this instance, right, is going to be the value of speed. Okay, so I hope that makes sense. Now let's look at interfaces in that. Right, I would like to look at it from here. An interface defines the syntax that any entity must adhere to. Right, interfaces define a set of methods available on an object that does not have a syntax for declaring interfaces. Class declarations themselves are interfaces. So classes should use the implements keyword to be able to use an interface. It is mandatory for the implementing class to provide a concrete implementation of all the functions of the implemented interface. In other words, the class must redefine every function in the interface it wishes to implement. Okay, let's just go straight to the examples and see what we have. All right, so there's nothing much here, right? This is just similar to what we have already done. All right, let me go back to inheritance and copy maybe one or two of these. Okay, so interfaces. Every class is actually an interface, all right? Like this shape class is an interface. Okay, so what I can do is I can inherit from this. I can inherit from this by using implements, the implements keyword. All right, so what this implements keyword does is that it insists, just as we had in abstract classes, all right, it insists that I override any method that is in the parent class. Okay, I must override any method that is in the parent class when I use the implements keyword. All right, so I must override this call area. All right, so like this. Okay, and what again? I have to even override the properties. Okay, so I'll just define them also. Surface area and string color. All right, so that is what implement does. It just insists that whatever any class I am implementing, since I am implementing from a parent class, right, I must override the methods and as well define every single value inside that is in the parent class in the child class. All right, it doesn't happen that way with extend. Extends just inherits from the parent class. All right, everything that is in it. Okay, so I hope that was enough explanation, right? I have gone through abstract classes and interfaces. Okay, so let's call it a day, and I'll see you in the next lesson. Thank you.